Now let us see that here the output current I0 waveform of single phase full wave converter with RLE load is continuous in nature, as V0 is continuous, that is positive cycle period, one pair of thyristors start conducting, and in negative cycle period another pair of thyristors start conducting. That's why simultaneously one pair after another pair which will continue to drive the load, and that's why the waveform of V0 will be continuous in nature on this solid line only due to the presence of your back EMF of DC motor. And then output current I0 which will be also continuous in nature, and no cases the output current touches the omega t axis. That's why whenever output current I0 rises maximum value, approaches to 0 in that point due to the inductive load, it will be extends towards this portion, and whenever approaches to again 0 in that portion before starting to 0, again another pair T3 will turn on, then similar process will be repeat to increase more, again opposite to 0, in the meantime another pair T and T2 will be turned again, and this process will be continued. So that due to the presence of the presence of RLE load and the presence of two pairs of thyristor, the output current I0 waveform will be somewhat improved in nature. And then come to the IS, the current across the thyristors IS. See that here the IS current which will be arises only when T1 T2 will be on state. This is due to the T1 T2 on state, so current portion will be like this, and this one it will be T3 T4 on state, or this one in negative cycle period, that's why this portion will be like this. And then again T1 T2 will be on during positive cycle period, so the thyristor current will be like this. And whenever after this portion again T3 T4 will be arises, and this will be shown in the negative cycle region. Then come to the load voltage average, calculation of average output voltage V0 and average output current I0. So V0 is equal to simple line 1 by 2 pi integration alpha to pi plus alpha beta into Vm sin omega t d omega t. That is equal to Vm kept outside, that is Vm by pi whole into minus cos theta limit alpha to pi plus alpha. Then by simplification we can get V0 is equal to 2 Vm by pi into cos alpha, where V0 is the average output voltage, Vm the maximum voltage, and alpha is the firing angle of the thyristors. And T1 T2 are trigger at alpha and pi radian, later T3 T4 are trigger in a particular sequence. So this one all about the average output voltage and average output current. Then average output current I0 is equal to 2 Vm by pi r into cos alpha. This one is all about single phase full wave converter with RLE load. Then come to the single phase semi-converter circuit or half control converter circuit. Before study about this circuit, we must have to know what the actual meaning of semi-converter or half control converter. Whenever the circuit comprises of a mixture of diodes and thyristor, then we can say the circuit is said to be a half control converter or semi-control converter circuit. In that case, the circuit comprises of one pair of thyristor T1 T2, one pair of diodes D1 and D2, and then a freewheeling dot FD also connected across the load. The load is nothing but your RLE load is connected here. And then T1 T2 are arranged in the upper portion of the bridge circuit, and diode pairs are connected in the lower part of the arm of the bridge circuit. And freewheeling dot FD is connected across the load, and the load is RLE load is connected across the output of the circuit. Then Vs is equal to Vm sin omega t is the source voltage given to the circuit. Then see that here Vs, Is are the source current, source voltage, and V0, I0 are the load voltage, load current respectively. And IFD is the freewheeling diode current. Then this portion nothing but your terminals A and the terminal B of the supply terminal lines. And then come to the diagrams or the waveforms of single phase semiconverter circuit. See that here this one is due to the source voltage Vs waveform, that is sinusoidal in nature, that is starting from 0 value, again reaches maximum value, and again finally 0 at the pi region. After pi region it reverses its polarity, that means up to 2 pi region. So pi to pi region negative half cycle period arises, again after 2 pi region again another positive half cycle arises up to 3 pi region, again after 3 pi region again another positive half cycle which will be negative half cycle will be arises. So in this way periodically it will changes its polarity as well as its magnitude from time to time. So Vs is the source voltage with respect to omega t. Then come to this one is the line parallel to omega t axis, that is back EMF line or the motor EMF line. So this one is the load voltage V0 waveform, this one is the sequential order will be represented here. Let us come to the operation of single phase semiconductor circuit with freewheeling diode connected with RLE load. So that during conduction period at a time one pair of device which will be start conducting, that is one from thyristor group and another from diode groups. Suppose initially the pair of the device T1 D1 which will be start conducting, in that case T2 D2 are in off state. So whenever T1 T2 will be conduction period, during positive cycle period the path of the load current will be Vs, T1, then load, then D1, again load source voltage Vs. And in this period T2 D2 are in off state and FD is in off state, and this will be shown in alpha to pi region. So after pi region the supply voltage reverses its polarity, that is positive half cycle negative arises. In that case T1 D1 will be turned off and then FD which will be start conducting this portion. From pi to pi plus alpha region FD start conducting due to the stored energy across the inductor L. Whenever reach at the pi plus alpha region, again see that entire total energy of the inductor L which will be dissipated, and then T2 D2 will be start conducting. So the waveform will be like this. This is due to the T2 D2 driving voltage. Then after the instant of 2 pi region, again T2 D2 turn off and the FD start conducting. So this portion will be V0 will be 0 due to the field node FD start conducting. Then at the instant of 2 pi plus alpha region, again see that again T1 D1 will start conducting. This portion only due to the load voltage across the load due to the sequence or the conduction period of T1 D1 conduction period. And this way V0 waveform will be continuous, but that is a break period only during FD conduction period. So you can write the sequence of load voltage V0 will be alpha 2 pi, then 2 pi plus alpha to 3 pi, then 3 pi plus alpha to 4 pi, and so on. The output current I0 will be continuous in nature, and see that here the sequence of T1 D1 FD, T2 D2 FD, T1 D1 FD, T2 D2 is clearly marked here. And this one shows the freewheeling diode current waveform. The FD start conducting only during the pulse period. This is the period FD increases and finally maximum and then 0. Then total 0, again it increases and starting falling and finally 0. Again start increasing and reaches maximum, again fall to 0. In this way the field diode current which will be waveform will be marked here. Then come to the voltage across thyristor T1, that is VT1. The voltage across T1 or T will be arises during negative cycle period. That is in negative cycle period whenever T2 D2 T1 D1 on the off state, that is pi plus alpha region to 2 pi region, and then 3 pi plus alpha region to 4 pi region. In this way we can see the voltage across thyristor T1. Then we can see the voltage across thyristor T2 only during positive cycle period because it will be conducting negative cycle period. So the path of the current of the load voltage sequence, the voltage across thyristor T2 V2 sequence will be alpha 2 pi, then 2 pi plus alpha 2 3 pi, then 4 pi plus alpha 2 5 pi, and so on. In this way the voltage across thyristor T1 T2 are marked, represent alternatively simultaneously during turning on and turning off process whenever the load will be drive. Then V0 is equal to 1 by pi alpha to pi Vm sin omega d omega t Vm by pi into cos alpha.